For this example video of what your Zoom interviews will look like, I'm going to be playing two roles. So when you see me in the messy faculty office with the suit jacket on, I'm Dr. Bartz. And when you see me in the dorm room with a ball cap on, I'm Sean, a student in Physics 105. All right, so now that you've met both the characters, let's go ahead and get started. Okay, so this question says that there's a catapult that launches a balloon with the velocity and at the angle shown, and the angles measured from the horizontal. If you place it 5 meters from your friend's dorm building and launch it at their window, which is 7 meters above the ground, will it hit their window? How would you go about answering this question? Well, so it looks like this is a problem with projectile motion because we have, once the water balloon leaves the catapult, the only thing acting on it is gravity. So we know it's going to be in free fall. The acceleration is going to be negative g, negative 9.8 meters per second squared. And the equations that I'm going to use are going to be then 3 through 8 in some of them. So the thing that I want to figure out, my target quantity is the height, right? So how high the water balloon is when it hits. So that is going to be from equation 6. That has y involved. And I know y naught, that can just be 0 at the ground. Initial velocity, v naught y. Well, I know v naught and I know the angle, so I can use equation 8 to get the vertical velocity. I know the acceleration is negative g, so that's I can use that. But I don't know time. I don't know time, so I can't use equation 5 to get that because I don't know the final velocity, vy. So I'll have to use equation 4 to get that. And I know everything else in that equation except time. So I can, I know the starting position is 0. I know the distance to the wall is 5 meters. So I can use equation 7 to get the x component of the starting velocity and use that to find the time. And once I know the time, I can calculate the height and see if it's 7 meters when it hits the wall. So that's how I would solve it. Okay, great, Sean. That's exactly how you would go about solving it, and you identified the concepts correctly. Okay, so that's right. And if you, it turns out that if you did the calculation, you would find that the height that you got was less than 7 meters. So knowing that, how would you figure out if you could move the catapult somewhere to see if there would be some position where you could place the catapult and be able to hit the window? Well, no matter where I put the catapult, it's always going to shoot at the same velocity. So what I would want to figure out is what the maximum height the water balloon could get to. Could it even get to 7 meters? So again, that's using equation 6. But again, I don't know the time. And because I might want to change the distance from the wall, I can't use equation 4. So that means I'd have to use equation 5. Well, that's so when it reaches its maximum height, its final velocity there is going to be 0. So I can figure out how much time it takes to reach its maximum height using equation 5 and use that in equation 6 to find what the maximum height is and see if it's at least 7 meters. If it's at least 7 meters, I could probably hit the window. But if it's not 7 meters, then there's no way to hit the window. Okay, good. And as another follow-up, since you did so well, would you, or how would you tell if you should move the catapult closer to the building or farther away? I'm not really sure. Could you give me a hint? So the hint would be, how would you tell if the balloon has already reached its highest point when it hits the wall if it's 5 meters away? Oh, okay. So, I guess, well, now I know, I would know what the maximum height is. So I could compare it to that. But that wouldn't tell me if it's on its way up or on its way down. So I guess for that, I'd have to calculate its vertical velocity when it hits the wall. And if it's positive, then it's still on the way up. So I'd want to move farther away. So that was an example of a well done interview. The first question was answered quickly and without any prompting from the professor. And then on the follow-up, I wanted to show an example of what it would look like if there was a little bit of prompting. So if you get stuck on the first question, I'll give you a little prompting on that, and you can see on the rubric kind of how that would detract from your score. On the follow-ups, there may be one or more, and if you need a little prompting on those, that's the follow-up question you can kind of think of as bonus points. So again, make sure you check out the rubric and make sure that you're signed up for an interview time. All right. Hope doing this dumb little character thing made it a little bit easier to watch.